1.6 is on roots and radicals. A radical, or a root, is the mathematical opposite of an exponent. Since 5 squared is equal to 25, then the square root of 25 is 5. And these are the symbols used for roots and radicals. You have the radical symbol. Inside the radical symbol, you have the radicand. Outside, we have an index if necessary. And if there is no index, then we assume 2, a square root. And altogether, this is called a radical. This one would be pronounced cube root of 27. When finding square roots, the number 2 is key. When finding square roots, we are finding the number that when multiplied by itself 2 times, it equals the radicand. So you are looking to factor the radicand into 2 equal factors. So for the square root of 16, you ask yourself, what is multiplied by itself to equal 16? And we can factor 16 into 4 times 4. And so the square root of 4 times 4, we can see there that we have 2 equal factors. And the square root is one of those 2 equal factors, which is 4. As a side note, since there aren't any other factors, 16 is called a perfect square. For cube roots, 3 is the key. When finding cube roots, we find the number that when multiplied by itself 3 times is equal to the radicand. So for the cube root of 27, we need to factor 27 into 3 equal factors, which is 3 times 3 times 3. The 3 equal factors, the cube root is one of those 3 equal factors, which is 3. Another side note, since there aren't any other factors, 27 is called a perfect cube. A very important property of radicals is that the root of the product AB is equal to the product of their individual roots, root A times root B, only if A and B are positive real numbers. Simplifying radicals means to remove the perfect square radicals from the radicand and leave other factors under the radical sign if there are any. So let's look for simplifying the following. If I factor my 25, it is 5 times 5. Those are 2 equal factors. We don't have an index stated, so we assume it's a 2. We are looking for one of 2 equal factors, and since those 2 are equal, the square root is 5. Again, in the next one, we're doing a square root since there isn't an index. So we want to look for one of 2 equal factors. Well, 32 factors into 16 times 2. And 16 can be broken down some more, which is 4 times 4 times 2. Well, applying the property of radicals, we can do this part separately, and the other one can be left outside. The square root of 4 times 4 is a perfect square, so that's equal to 4. This one cannot be factored anymore, so it must stay as root 2. As a side note, this is called a mixed radical. It consists of a whole number and a radical. Let's take a look at the cube root of 8. Cube root of 8, we can factor into the cube root of 2 times 2 times 2. And for cube roots, we look for one of 3 equal factors. There are 3 equal factors there, so the cube root of 8 is one of those, which is 2. For the cube root of 24, let's factor. We have the cube root of 8 times 3. Well, we do know the cube root of 8 already. We just did it above. And then what's left over is the cube root of 3. The cube root of 8 is 2. And we cannot factor 3 anymore. It's actually a prime number. So it must stay in radical form. Again, we have a mixed radical. Now, my main reason for explaining all of this is not so that you will do this manually, because most likely people will be using a calculator when finding these values. But what's more important is to understand what's going on with radicals so that we can apply those ideas to algebraic expressions. So the square root of x squared can be written as the square root of x times x. I'm just factoring my x squared into 2 equal factors. And so therefore, the square root of x squared is equal to one of those 2 equal factors, which is x. Let's do the same for the square root of x cubed. When we factor x cubed, it's x times x times x. Well, we do know this part so far, up to 2 x's. So let's write it that way. And there's one left over. It will get its own root sign, very similar to the factor 3 that got its own and had to stay under the radical sign. So this is equal to x root x. When we move down to the square root of x to the 4, well, that can be x times x times x times x. To simplify that, that's x times x times x times x. Oh, look at those two, both perfect squares. The square root of this one is x. The square root of the second one is x. So therefore, the square root of x to the 4 is equal to x squared. Do you notice a pattern? If the exponent is even for square roots, this becomes a 1/2 of that. Another even one is the 4. Became half of 4, which is 2. This one, if we want to find it, we always know that for an odd number, there will be 1 left over. That's this guy. And so x squared times x, well, that turns into x root x. I'm going to leave for you the square root of x to the 5. Pause the video, follow the same pattern, and find out what it would be. So this is equal to x to the 4 times the square root of x to the 4 times the square root of x. The square root of x to the 4 was done up top here. It is x squared. There is a square root x left over, so that will be there. Now, I could be really kind of silly and actually add one more in here. The square root of x to the 103. Let's break it down the same way. The square root of, it's an odd number, so I know I'm going to get 1 left over. That's the 1. This must be x to the 102. And when I do the square root of x to the 102, remember the pattern. The 4 was cut in half to the 2. The 2 was cut in half to 1. So 102 should be cut in half. X to the 51 root x. Okay? Kind of silly one, but I thought I'd show you the pattern. Okay, for the square root of 9x squared. That's the square root of 9 times the square root of x squared. I'm only breaking it up to let you see all the different parts. You don't have to write it this way. 9 is a perfect square. The square root of 9 is 3. The square root of x squared we have seen, which is x. The square root of 18x cubed. Well, the square root of 18 and the square root of x cubed. Break this down a little more. This one's actually the square root of 9 times the square root of 2 and the square root of x squared and the square root of x. So let's go over here with it. So this will be 3 for the square root of 9. The square root of 2 I can't break down anymore. The square root of x squared is just x, and the square root of x we cannot break it down anymore. So it's more customary to write the whole numbers in front. So this will become 3x square root 2x. All right, expressing roots using fractional exponents. The nth root of x is equal to x to the power of 1 over n. So some numerical examples are here on the side. The square root of 25 is actually equal to 25 to the power of 1/2. Or the cube root of 27 is actually 27 to the power of 1/3. Using our fractional exponents, we could simplify this also, and it works out to be x squared, the radicand, all to the power of 1/2. But remember from properties of exponents, power on a power means we need to multiply them. So it's x to the power of 2 times 1/2. Well, 2 times 1/2, that's 1. So that's x to the 1, which is just x. Taking this property a little further, if we have a power inside the radicand, then the nth root of x to the m is actually equal to x to the m over n. So this one numerically would become x to the 5 over 2. Let's take a look at one on the calculator. So I'd like you to pull out your calculator and take a look for these two keys on it. Okay, so in looking for the xth root key on the calculator, on this particular one, it is the second function you will see, or actually beside this one, the y to the x. The second function of it is the xth root, so it kind of looks like the x, it's got an x in front of the root sign as the key on the calculator. So we're going to use that. And on this calculator, and every time I touch my screen, the calculator goes away. So on this calculator, we need to put the index in first. So we'll tell it it's an index of 2. Then I will use the xth root key, but for the orange function there above the y to the x, I have to hit the second function key and then that. All right, so it's showing that I'm doing the square root of, now I want to enter 3 to the power of 5. The y to the x is the power key, so we put the base in first, 3, hit the y to the x, to the power of 5. So this calculator is quite nice. It's called a right view. It's actually showing it on the calculator exactly the way we have it written here. And we'll hit equals. Now on these new right view calculators, they actually leave it in radical form if possible. So this came out to 9 root 3, and we could kind of break this down and take a look at why. If you have a right view calculator and you're wondering what to do with that and what value that actually is, there is a change button on here that will change it to decimal. So it's roughly 15.6. So take a look on your calculator for these two newer keys, the xth root, it could be a second function. your y to the x. We could also then enter this as 3 to the power of 5 over 2 using a fraction key. That's another key on the calculator I want you to look for. On this one, it's right here. A over b, or the second function of it is a mixed fraction, a b over c. To use this fraction key, let's clear it. We're going to enter the base 3, and we will raise it to the power of, now I'm going to raise it to the power of 5 halves, so I'm going to do 5 a over b 2. So it's now 3 is raised to the power of 5 halves. Let's press equal sign. Same number, roughly 15.6. Okay, that's about it for roots and radicals. Take a look at your calculator for those buttons. Practice some of the homework with the calculator and without. The homework suggestions are 1.65 to 17. Thanks for watching. Bye.